Okay. All right. Division of polynomials. Polynomial meaning we've got several terms. We've got letters and numbers and pluses and minuses. Division. What are the symbols that we use in math for division? There's about 3 or 4.
Division sign.
That one.
Yeah.
Good. All right. There's this symbol. What else do we use?
The
dot.
The other division sign.
Like.
Oh, like this.
Yeah.
Yeah. Yeah. We usually write that in ratio, but other than ratios, I can't think of any other time we use it. So I'm going to leave that off.
A fraction.
The one, yeah.
A fraction.
And then
So like a numerator and denominator of a fraction. All right,
okay.
So typically we've used this symbol for division in math.
Yeah,
Especially
usually.
Fractions. A fraction is another way to say division. Whatever the numerator is, the numerator over the denominator as a fraction is the numerator divided by the denominator. What's another symbol? Any of you remember how to do long division?
So it's.
Remember that symbol?
Yes. I don't know exactly.
That one?
Oh yeah.
Or I think some people do it like this.
Okay.
Yeah.
All right. So if we talk about division of polynomials, let's say we have a polynomial. This is example 86.1. Let's say we've got 3x cubed plus 7x squared minus x, and I want to divide that by x.
By x?
I'm going to divide that by x. I could write it like this, which would be the same thing, which is another way of saying I need to divide everything by x. So I could write it this way. With me still?
Yes.
All right, so that would be 3x squared plus 7x minus 1. By the way, when you factor something out, that factoring out is the opposite of multiplying, and division is the opposite of multiplying.
Oh.
So it's kind of like, so if I have this polynomial here, and I divide by x, I'm doing the same thing as factoring out an x. That's just a different way of writing it. It's just a different way of saying it or writing it. All right. There's 9,798 divided by 27. What's the process for long division? So 27, does that go into 9?
No.
No. Does 27 go into 97?
Yes.
How many times?
I think it's 3, but I'll do math. I don't really know, I guess.
Yes, it's going to be 3.
Well,
All right. How many times does 27 go into 97? And you write that number up here. That's 3 times.
No, there's still some remaining there.
Well, yes,
81.
I know, but it goes into a max of 3 times.
Yeah.
All right. Then what's the next step in long division?
Go to the next one.
Well, you put that number, like 81, underneath the 97.
Yes. I need to multiply. I need to multiply this number times this number, which is 81. Right? All right, see how many times it goes into, and you write that above. Then you multiply that and write that down below, and then what do you do?
You subtract.
Subtract 87 from 81.
So then the next step is to subtract. So I'm going to subtract that, and what do I have here?
16.
16. What's my next step?
Put the 9 down.
9.
Okay. Okay. What's my next step? I repeat back to here, right?
Yeah.
So 27 goes into 169.
6 times.
The 6 times? Okay. And then the next step is to multiply. So I write a 6 up here, and 6 times 27 is
162.
162. And then my next step is to subtract again,
7.
which is 7. And then I bring down the next digit,
4.
which is an 8. And I do it again.
It goes in there twice. I'm pretty sure.
Goes in
Yeah,
there,
twice.
twice. So I write the 2 up there. Then I multiply 2 times
54.
27 is 54. Then I subtract
4 and 24.
24. And then finally I do I have my remainder, right?
Yeah.
Oops. For the remainder, whatever my last remainder here is, whenever this doesn't go into this anymore, my remainder, I can put this number over the divisor as a fraction. 24 over 27. So the answer to this question would be 362 and 24 over 27. Okay, so this brings back all sorts of wonderful, happy memories.
Nope.
Now we're going
Is that
to do
it?
the same
I
thing
hope so.
with letters.
Oh.
Oh my gosh.
The good news here, relatively speaking, is that it's the exact same process. Let's see, so we're going to take a look at 86.3. We're going to divide negative 2x squared plus 3x cubed plus 5x plus 50. We're going to divide that by negative 3 plus x.
Oh yay!
Now, what I'm going to add a first step here is to write all the polynomials in descending order of the power of the variable. The way you typically write things. So the dividend, the number that is being divided, or that you're going to go into, when it's being divided by, what's the highest power term in that? Example 86.3.
It would be.
Is there an x? Is there an x in there?
Yeah.
Is there an x squared?
Yes.
Is there an x cubed?
Yes.
Yeah.
Is there an x to the fourth?
No.
All right. So the x cubed is the highest power term. What is the x? So that's 3x cubed. What's the x squared term?
Negative 2x squared.
What's the x term?
5x.
Plus 5x.
Yeah.
Okay. And then the number?
Negative 3 and.
No.
Oh, 50, sorry.
Plus 50.
Yeah.
All right. So I put that one in descending order of the power of the variable, and then I'm going to divide that by negative 3 plus x. Negative 3 plus x. Also put that in descending order. So do x minus 3. All right. So we're going to do our loop. These are the things that we do over and over again. All right. How many times? So x minus 3. Let's take a look. Consider the x mainly. How many times does x go into 3x squared?
3 times.
3 times.
3x squared times. Right?
What?
What?
Here.
If you just
27
use 3
times what gets us close to 97? 27 times 3 does. X times what gets us 3x cubed? 3x squared.
But X
Well,
was
x, right? 27 times 3 to get this that we're gonna subtract. X times 3x
What
squared.
about that negative 3?
We'll get there in just a second. 3x squared times this. 3x squared times x is 3x cubed. But there's also minus 3, so we can also do 3x squared times this.
minus 9.
So minus 9x squared.
And now you subtract.
Now we're going to subtract.
I already lost you, just saying.
Yeah.
Distribute. Sounds good. Well, that doesn't help.
I need to subtract all of this, right? Both of these terms from here. So I can't just do this. I have to change both signs, right? Because I need to subtract that. Subtract the 3. I've got 3x cubed minus 3x cubed. So this goes away. Negative 2x squared plus 9x squared is.
Oh, a chance
6x
now.
squared.
That's right, 7x squared.
Oh. Wow.
Now, let me point something out to you. If any of you look at the book says mentally change this sign.
Okay, that's fine.
I think that is a horrible idea. Write it down.
Whoa, chill out, Mr. Green.
I know, write it down.
And I know how.
Whoops.
So what's my next step? So after I subtract, what's my next step?
So you basically do the 60.
Bring down. I'm going to bring the 5x down. And then I do it again. X times what gives me 7x squared?
7x.
7x, a positive 7x. Then I'm going to multiply 7x times this, 7x times x,
7x squared.
and 7x times negative 3,
21x.
negative 21x.
Wait.
But you
oh
now
my
change the
gosh.
sign.
So I did the 7x times this, and put that
21.
here, the multiply step.
Oh my gosh.
But now you have to change the sign.
7x times this is this.
Okay.
All right.
Wait.
And we need
That's
another
cool.
sign.
Oh.
Yeah, I get that how you did the 21x.
Okay.
All right. And now I'm going to subtract. Got to make sure I pay attention to
So those
change both
cross
signs. So this goes away. We've got 5x plus 21x,
26x.
26x.
Oh, it would be
Then I bring down the 50.
Wait, it would be 26x squared.
No, we're
You
adding.
add the
We're adding.
x's.
That's only in
We're adding.
multiplication.
5x plus 21x. We've got 5x's plus 21x's gives us 26x.
Okay.
All right. Then we
Then
bring down the 50, and we're back to our how many times does it go into?
26.
X times what gives us 26x?
26.
8.
26.
26. Then we multiply 26 times x minus 3, 26x minus
I don't know.
73.
And you change the sign.
What?
Whoa, whoa.
No,
wait,
no, I'm sorry.
26 times
78.
I'm like, bro, how the
I'll do it.
78.
Negative
Is that
78.
Okay. Then our next step.
I'm like, change the sign.
Our next step, we're going to subtract and change both signs. What do we have here?
8 plus 12.
128.
Yeah.
Okay. Now x. Now we're to the end here. There's no more x's here. So this is going to be our remainder. Our remainder is the 128, and it's a positive 128 over the divisor. Just like we did here. We got to the end. We put the remainder over the divisor as a fraction. We got to the end. We put the remainder over the divisor as a fraction. So the answer to the question is this right here. Okay. Example 86.6. Sometimes there are, you don't have all the terms. So you might not have an x squared and an x term in a dividend. Example 86.6 says divide negative 4 plus x cubed by negative 3 plus x. So following our steps here, the first step is to write the polynomials in descending order of the power of the variable. So we want the x cubed term first, but there's no x squared term or an x term, it just goes to a number. You need to leave a space for it. So the best way to do that is to write 0x squared and 0x, and then we get to what the next thing that we have, which is a minus 4. If you don't leave a space for whatever powers are missing, then it's going to mess up your process. So make sure you always check for that. So we're going to take this and divide it by negative 3 plus x. We want that in order also. X minus 3. All right. So we follow our procedure.
Here we go.
X times what goes into x? It gives us x cubed.
X squared.
X squared. And
Please.
so we're in here. What's that?
No.
All right, so x squared. Then we multiply. X squared times this gives us x cubed minus 3x squared. Then we subtract, change both signs. X cubed minus x cubed goes away. 0x squared plus 3x squared is 3x squared.
Wait, why is
So
it?
because we're going to end up with an x squared anyway, that's why we need to leave a space for it. So we have a column for it. All right, so we subtracted there. Then we're going to bring down just 0x. Again, that's just to hold the space. And we're back to how many times is what x times what gives us 3x squared?
3x.
Positive 3x. Then we multiply 3x times this gives us 3x squared minus 9x. 3x times x is 3x squared. 3x times negative 3 is minus 9x. Yeah.
So why not, when you multiply x squared and negative 3, why is it not negative 3x?
It was. But when I subtracted, I had changed both signs. I'm subtracting this whole thing. So
So you're
it's,
subtracting.
yeah, this brown and that red, the color's pretty similar. So what it was this. X cubed times x is x cubed, or x squared times x cubed, x squared times negative 3 is negative 3x squared. But then when I subtracted, and I had to carry through the sign change.
And that's only if you, because right now you have to change the signs again.
Because what it is this, I need to subtract this.
Yeah.
And so if I don't want to write parentheses every single time, rather than writing parentheses and then distributing the negative, saves me some writing. Because I'm subtracting that whole thing. Right? All right, so now I'm going to subtract. So I change both signs. When I to subtract, 3x squared minus 3x squared, nothing plus 9x is 9x.
And you,
Next step, bring down, the next thing is a negative 4. So I brought down the 4, and then I'm going to, last time through, x times what gives us 9x?
3.
3.
3.
9.
Or 9.
9.
Oh, yeah.
Oh, x.
Then
I thought you were asking.
I multiply. 9 times x minus 3.
9x.
9x minus 27. Then I'm going to subtract.
Okay. So you have to
change both signs.
So that would be a 23.
And that's going to leave me with a positive 23. I have run out of x's, so I can't say x times something. So this is my remainder. It's a positive 23, so positive plus 23 over the divisor. And here is my answer to that problem.